Hey everybody, Brian here from Matlab.net. Okay, so in this video I'm going to show you how to do multiple deployments from a Simulink model. In a previous video I showed you how to use MuPad and generate a Matlab M function. I'm going to do something similar to this, but I'm going to show you the difference of what I did. I'm only doing this for very stripped down basic versions just to show you the potential of what this Matlab Simulink can do. Okay, so here we are in a general tutorial, quite good I must add, on MathWorks. This is a simple model that we're going to create in Simulink, and all the canvases that you work within are what's called models. And then you have subsystems and blah blah blah. So right now I'm just going to create one model with a set of blocks, and I'm going to show you how to do this visually. So the first thing is when you type in Simulink in the command window in MATLAB. I've shown this numerous times, but I have a serious amount of new people. So I'm showing this again, hopefully the last time I need to do this. And what I'm doing is I'm creating this model right here. It's called Simple. Simple, right? And part of that, you have a Simulink browser. You can easily come under here under Library Browser, Model Viewer, that sort of thing. So we're going to look at the Library Browser. Now, each one of these is basically a block. Okay, so this is the input of just a basic sine wave. It's just going to generate random sine wave. This little guy right here is going to integrate that sine wave input. So there's going to be two inputs coming out of that into my custom M function. So when you want to look for a block, all you have to do is just type in this case, Matlab Function, and it'll display it, and you can just drag and drop. Simple as that. You kind of like that, right? All right, so knowing that, this is visual. So you may not be strong in programming, but using the Simulink is quite powerful because it's visual. So what we're doing here is we're generating a sine wave. We are also taking the integration of the output of that. And you can see here each block has inputs right here and outputs. Simple stuff, right? So this sine wave has no input, but just generates one output, which is just an output of a sine. The integrator basically has one input, one output. So let me show you that. I'll type in integrator here, show you what I mean. Okay. Alrighty. Here we go. Let me find my little integrator here, somewhere in here. Let's see. Yeah, this one. Okay, so you can see here, this is an input, that's an output. So I can take this little output and move it to there. Simple as that. So I'm just going to replace that, change. You can see it also has an output. So it does something, and then just has an output. And you can plug and play that into here. Simple as that. Pretty nice, eh? Alright, so we have this sine wave, we have an integrator. We also have a Matlab function that you can customize. Now, again, it's a block, right? So here's our Matlab function, and all you have to do is, in this case, double-click it, and it will bring you into the Matlab editor. So in my case, let me just go back into the model canvas thing, get rid of that. Here is what was created. Right. So all we're doing is really simple stuff. We've got two arguments of input, x and y, and return a z. And it's just a multiplication between the x and y. Simple. So that's basically what this Matlab function does. So it has the two inputs, two arguments as I call them, or two parameters of x and y. It has resulting of z, and that's the output, and then it gets thrown into a scope. Now, when you run this, all it does is it will, let me just show you, I got two screens here, so I'm going to apply it. So it's going to run it, and it'll go beep beep, whatever. That means it's run. But this is the output. Now there's different outputs that you can get. As I've hinted before, with the new 2015 version of Matlab, you can use now gauges. So if you come under dashboard, there are various, under these dashboard here, you get all these different gauges. So you could put a gauge here, and basically it'll be like a dial. But I still got to figure out how to use this. But it's quite good for a variety of things. So you can build a very sophisticated model, in my case a future and option trading system with a model, and put these little gauges in there as outputs to measure things like basis or who knows what. So we know that this runs. So here's the cool part. Now remember I said there's 2, maybe 4 options that you can deploy now. This model is Simulink, and you can deploy them into Cogeneration using the Matlab coder as the underlying technology. Using that, you can generate C or C++ from it, and you can also generate HDL, which is really meant for FPGA, which is of course our favorite high frequency trading boards, custom boards, but they're very expensive. But we're not going to go there. That's going to be down the line. But we can still generate some C or C++. So what I'm going to do is I'm going to generate C code. Okay, I'm going to walk you through this very fast. So if you come under Cogeneration options, what you get is you get different targets. I'm just using a generic target. My language is going to be C. I've already chosen my target compiler to be the Microsoft Visual C++ compiler. And I can just generate code only. There's some other configuration that you need to be walked through, but I just want to show you that it works. Now, let me just show you. Now, I purposely kept this model very simple for the fast coding generation. So we need this. Now, before I forget, there's a couple of things I want to show you here as part of the interface for the coder, this is really the Simulink coder, which is using the Matlab coder, the underlying technology of it. So here you can, within your model, when it starts up, when it terminates, a header, custom files, you can deploy them into this section here. So you can have custom C as part of your model. You can also build other custom C using Fortran C, using S functions as well, and they can be part of those blocks that I told you about. These guys, each one of these is a block, so you can create an S function to essentially create your own custom block. That's very cool. Yeah, so let's go back to our options. I got so many windows here. And here, okay, so we also have the ability to generate a report, which I wanted to show you. Comments, this is powerful. You don't have to put all these comments in, but you can just click them. But I just want to show you all the steps and all the comments that can be generated from the cogeneration process, and I'll show you that in the code. All of this I'll put up on my GitHub as an example of how this works. And yeah, so we can add in our Simulink block code, comments, anything from a state flow chart as well, and that's great for tracing back within our Simulink model or state flow chart. I haven't shown the state flow yet. We can generate Matlab Sources comments, so that's actual source code from within the Matlab functions, M functions that we've talked about. We can show eliminated blocks and storage class if you want that as well. I just go crazy on it for now. Okay, so let's go to the cogeneration now. And there's one little window I want to show you here. It is a Diagnostic Viewer. Okay, so what it will do is, I think that's what we want. Yeah, that should do it. Okay, so I'm going to press build. And here we go. So it's going to generate the report. I'm going to show you what it's doing. It's generating all the C files for us. And that's it. Now remember, we did it very simply. We've got a couple of C files, a header file, We have some utility files as well, which is part of the supporting Cogeneration. It's still fairly efficient, and I'll put this up again as part of the GitHub. But remember I talked about the comments. These are really important for tracing back, so that you can say, oh, let me think of an example here. So here's our model step function. Here's our sine wave block, and that's how it's generated, and that's what it would look like in the code. So you can use this stuff as a way to trace back to the model. So this sine wave block right here refers back to this guy right here, to that block. So that's the C code, the C equivalent of that block. So you can see the power of it with this. Right? Now you can build projects, solution files, and solution projects within Visual C++ and Visual Studio. That can be done quite easily with the new 2015. I've done that before. I'm pretty impressed with this. Now this is just the C version. Next deployment I'm gonna do is the C++, and I'll do that in the next segment. So, hey, okay, second deployment choice is going from C to C++. There's another little slight change that you need to make in order to make this happen. Under the interface, if you're using C, under the interface, you may or may not be able to use the mat file logging. But if you're going to cogenerate in C++, you need to not have this clicked, otherwise you get some kind of error. Alright, so let's go back to generate now our C++ code. Okay. Oh, that was not a good, wise move. Let me go back to the Simulink model, and then come under options. Okay. So here's our options, and then we're going to C++, build. So here's our little diagnostic viewer. Okay, so that's now compiled. Here's our C++. Okay, again, those comments are very useful for tracing back into your Simulink model, the header file, and some other utilities. Now, from what I understand, you can minimize these code options, these files. There is a full way to minimize the code, but for now, all is good because we got code, and especially C++. So that's working. Now, the other question is, which I've never done before, is HDL. So I may or may not be able to get it working. Now, I've never done it in 2015, so I'll try that in my next segment. If it doesn't work, but I'll give it a whirl and see what we come up with. All right. Hey, Brian here. So I tried to get the HDL working for FPGA. It's a lot more complicated than one would think. So I'm just going to focus strictly on C, C++ for this process that I've just demonstrated. Not really interested on the FPGA side. I think I have to pull in some better resources to show me how to walk through that process. But for now, obviously the cogeneration with C or C++ is good enough. And we'll leave it at that for now. Hopefully in the next couple of months, or who knows, when I can get the FPGA working, because let alone getting access to a board and all that, it's going to be a dependency that may not be so easy. So at least I'm able to show it 3 times now in the whole process of the workflow. So it's quite sophisticated, and there's not a lot of other languages or platforms that can do this as well. And I'm pretty excited now, so I can focus now on my strategies with this Futures and Options course, as I will try to develop my MuPad models, the expressions, get them into a Matlab function, and then deploy them into probably a fairly big Simulink model. But this is just generally how it would work. So hopefully you liked it, This is the workflow in a nutshell. Again, taking from MuPad, generating a custom Matlab M function, and as I showed earlier in this video, how to generate from a Simulink visual model and be able to bang out C or C++ code for it. All right, and it's efficient code as well. Oh, and I can also confirm that there's true cross-platform compatibility between Windows, as I've demoed on, and the current version of 2015A in Linux. Everything's compatible. I've done both in both environments. They work great, and probably going to see more in the Linux environment as I try to move off of the Windows technologies. All right, talk to you later.